Hello again. So we have reached exercise 18, which is to find the maximum element of an array using an iterative function. So we need to find the maximum element. So we have already wrote the reading of dimension, the reading of array, and displaying the array. So here I have declared an array of size, the size. We have read the dimension and we have read the array. So we need to write a function that returns the maximum. So obviously the maximum is one of the element of the array, so it should be of type int since the array is of type integer. So max element, and of course we need the array, let's call it a, and dimension, let's call it dim. And we need to find the maximum. So obviously I need to loop. So we need an integer I, and we need the maximum. So at the beginning, the maximum would be equal to int min. So we already done that. So we need to be sure to include the limits dot h at the top of the program. So limits. So, and let's do a loop. So for I equal to 0, I less than dim, I plus plus. So if the element of the array a of I is greater than max, so I will modify the max variable, which will be equal to a of I, and at the end I will return the max element. So here I just need to print f max equal percentage d backslash n, and I just need to call the function max element. On the array here it's called t1 and of dimension as 1. So let's run and check. So okay, so we didn't pass the array. So let's say we have 5. I will enter the element 3, 8, 6, minus 5, and 8 also. So obviously the maximum is one of these 8. So this is a solution that we already know how to calculate the maximum. However, as we have seen, for example, if I want to sort the array, I don't getting the maximum is not beneficial, so I need to find the index. So for that I will be solving exercise 19. So in exercise 19 we need to find the index of the maximum element of an array. So we don't need the value, we need the index. For example, here if I want the first index, it will get me 1. If I want the last index, I will get 8. So we write another function called index max. So int index max array. So here I need the index. So obviously first I need the index. So I need to save the index. Obviously I cannot compare a of I with the maximum, because maximum I need here the index of maximum, and obviously the index first should be out of bound. It shouldn't be anything. So we can say that the maximum for now is of index 0, and I can start from 1, and I will compare a of I with a of I max. So we've already done that, and in I max I will save just the index. So we've already done that. So just pay attention that we cannot place, for example, here -1, because if I place, for example, -1, I will compare a of 0 with a minus 1, so a minus 1 is out of bound. So I should place 0. So I will consider that the maximum is the first element. So I will skip the iteration for I equal to 0. You can place it, so you will compare a of 0 with a of 0. So this is not that important. So let's print the index. So let's write here at index equal percentage d backslash n, and here I will say index of t1 and s1. So let's run. So again 5, 2, 8, 7, 6, and 8. So obviously here we will get the index 1, because I have here a strictly greater. So whenever I encounter 8, so 8, it will not get, I will not take into account this 8 because it's not greater than, strictly than 8. If I place equal here, it will give me the last index. So here is an example. So I have 2, 8, 5, 6, and 8, and here I will get the index 5. So all depends on the equality here on the test. So if they ask you want the first, the index of the first maximum or the index of the last maximum, and so on. So this is the solution. It's very easy. We just embedded the code that we have already written in the array part into a function. And this is it for this exercise. If you have any question, do not hesitate to write to me. However, now I had the idea to write this function recursively. So let's find the maximum of an array recursively. So I will copy this. So I will not get the index element. So it's the same. However, I will just work on the maximum element recursively. So in order, so I will just write the prototype here. And let's see how we can do that. So obviously we need a stopping condition. So for the stopping condition, and as I have already explained, so the recursive code would contain the same number of parameters. So I cannot change a, however I can change the dimension. So obviously I need to decrement the dimension since I cannot increment it to a very big number. So obviously I will reach a place where the dimension equal either to 1 or 0. So if the dimension is equal to 0, so as if I don't have an array, so there's nothing to do. So if the dimension reaches equal to 1, it means that there's just one element in the array. So obviously the maximum would be equal to a of 0. So there's just one element, and we know that the element starts at index 0. Otherwise, I need to recursively to find the maximum. So obviously if I have multiple elements, and so at the end I will have just one element, so I will consider a maximum, and then I have 4, so I will consider the maximum between 3 and 4, and so on. So what I will do that is that we will recursively we will be using somewhere the array A with the dimension a minus 1. It means that I have a smaller array, dimension minus 1. So what does it mean? It means that, let me repeat, I'm here, so I have this smaller array, and I have the index, which is this one. So I need to find the maximum of this array. So obviously it will equal to 5, and then I will choose the maximum between this array. So this function will return the maximum of this array, and I will compare it with this one. So what I will say that I will return the maximum. So I write a function between the maximum and a of dim minus 1. So just remember that dim is dimension, so the last index is equal at dim minus 1. So I will compare the last element of this array with the recursive function with the return value of the function. So I need to write just a function called max. So I already wrote that between two integers. So I will return, so if a is greater than b, I will return a, otherwise I will return b. So let's see if it will work. So let's run. So 5, 2, 8, 6, 5, and 8. And yes, I will get an 8. So the idea here is a bit difficult. So you need to do the memory state. So make the memory state. Do not try to understand it like this. Do the memory state, take the same example, and see how 8 works. So you need to pay a lot of attention about the dimension here, why it's minus 1 and why it's minus 1. And this is it for this exercise. If you have any questions, do not hesitate to write to me and I will answer you back. And again, thanks for watching.